The slope of line is the ratio of a rise for any 2 points on the line.
All right. So here's my little equation. And the thing is, this equation, we've seen it before. We've just seen it a different way. So remember what I said. Slope is the same thing as rate of change. So the rate of change formula, which we just used, y2 minus y1 over x2 minus x1, you can also use that for slope because they're the same thing. But if you have a graph like this one, and I know that this is a, how do I know this is a line or a linear function? I kind of just gave it away.
Because of the line.
It's a line, right? So I already know this is linear because I can see that it's a straight line. Straight line. But if I wanted to figure out what's the slope of this line, I could do two things. I could use the slope formula or the rate of change formula, or I can use this relationship right here called rise over run. So let me explain what that means. On this graph, I have 2 points. They've kind of labeled them for us nice and easy, and I see them nice and clearly. So I'm going to set up this little formula, slope equals rise over run. I'm going to color code everything just to make it very clear. And what that means, what this rise and run, what that means is I'm looking, I want to connect these two dots, but I want to do so by making a triangle. So I'm going to go make one going up this way, and then the other one's going to go across that way. So I'm connecting those 2 points by going straight up and straight to the right. And I want to count how far did I go up and how far did I go to the right. So can anyone, you got to count the units. It's going by 1. So how far is the blue line?
4.
4 units, exactly. 1, 2, 3, 4. How long is the red?
4.
Also 4, right? Okay. So that means my rise is 4. My run is 4. And now I have this ratio, this fraction, which in this case I can divide it easily. What's 4 divided by 4?
1.
Just 1. So my slope is 1.
So, Mrs., this is another way to find the constant rate of change.
Exactly. This is another way to find the constant rate of change. And what I want to show you now is that you would get the same answer if you used the slope formula. So I'm going to do the same. I'm going to now do the same thing. I'm going to calculate the slope, but I'm going to do so using the slope formula. And how do I do that? So I have these 2 points here. They labeled them so I know exactly what they are. And I can use those values in my formula in order to get my answer. So what you could do, if it helps you, is put this into a little table. Because for me, I'm a very visual person, and this definitely helps me. So I know I have -2, -1, and I have 2, 3. So based on that table, what's my y2?
3.
3, good. So I have 3 minus, what's my y1?
-11.
Negative, that's a 1, -1. And then x2 is
2.
2. So I have 2 minus -2. And remember, what happens with these double negatives?
They turn into a positive.
They turn into a plus sign, exactly. So I have 3 plus 1 over 2 plus 2. What's 3 plus 1?
4.
4.
2 plus 2?
4.
And 4 divided by 4?
1.
1. So notice I got the same exact answer because I'm technically doing the same exact thing. It's just 2 different ways. Some people, and this goes for like not just in math, but in like all the classes that you take, some of you guys are more visual, some of you guys are more analytical, more mathematical. You like numbers, you like adding and subtracting and using formulas. Whereas some people are more visual, they like to look at a graph, they like to visually see the rise and the run, okay? Me personally, I'm a little bit more visual. So for me, I prefer using rise over run. I like using the rise over run formula. But some people prefer numbers, they like plugging things in, they feel a little better about that. So some of you guys might prefer using the slope formula, the rate of change formula. So you can use whichever one you want, you can use whichever one you're more comfortable with, but it's important to understand that they're essentially doing the same exact thing. So do I have any questions on this so far? We're going to do another example in just a second. Cool. All right. So here's another one. Okay, so I'm going to do it both ways. And this time they didn't label the points, so we're going to have to do that ourselves. But let's start with the rise over run. So I'm going to find my rise and my run, and I'm going to set up my little fraction, my little ratio here. Okay. So I'm trying to connect these two dots by making a triangle. Now in this case, if I'm starting at this dot, okay, would I have to go up or would I have to go down to get to the other dot?
Down.
Yeah, I would have to go down because if I'm trying to get from here over to here, I need to go down instead of up. So I'm going to go down. And since I went down, my rise is going to be a negative number. Okay, so if you go up, it's positive. If you're going down, it's going to be negative. So in this case, what would my rise be?
-2.
I went down 2 units, so my rise is -2. And what is my run?
3.
Good, 3. So rise over run, what's my rise? -2. My run is 3. Can I simplify that fraction any further, or should I leave it just like that?
Leave it like that.
Yeah, I can leave it like that because you can't really simplify it any further. So my slope, my constant rate of change, is -2 over 3. Now remember, since I have a straight line, since I know I have a constant slope, that -2 over 3 will be the same no matter which 2 points you use. So in this case, they kind of told us to use those 2 points because it was labeled for us. Like they said, okay, use this one and use that one. However, I could have picked any point on this all along this graph that I felt like using. You really can use whichever 2 points you want, and you'll always get the same answer because it has to be constant, because that slope is not going to change no matter what. So we'll do another example in a minute where you can pick whichever points you want. All right, now I'm going to do the same thing. I'm going to show you how to get the same answer using the slope formula.
But Miss, why did you go down instead of going right?
Oh, good question. I could have gone right first. So instead of going down and then to the right, I could have done to the right and then down. But you still get the same numbers. You still get -2 and you still get +3.
Miss, why isn't it going up?
Okay, so the other way, let's say you wanted to do this instead. You wanted to go up first. So this would now be +2, right? And then, but from here, you would have to go to the left. So the same idea happens. If you're going up, it's positive. If you're going down, it's negative. Well, if you're going to the right, it's positive. But if you're going to the left, it's negative. So you would still end up with a negative fraction. It's just that now you're making your denominator negative instead of your numerator, but it's still the same. You get the same number.
I have a question.
Go for it, Jaira.
How do you know what is the rise and what is the run?
Okay, so rise, it's all in the word. Rise is up and down, So think about it. You rise because you go up, right? Rising means going up. Running, which direction do you run? Up, straight up into the air? No, you run side to side, right? So that's kind of where those words come from. So rise corresponds to up and down, and run corresponds to left to right. Mm-hmm. Okay, any other questions? Because I know this is kind of new, but don't worry, we're going to do a lot of examples. So if anyone has any questions, you can ask them now, or you can wait and see if they get answered later on. Okay, so now we're going to go ahead and use the slope formula, but in order to do that, I need to label my 2 points. So can anyone tell me any of these 2 points, what they are? What's the coordinates of these 2 points? Mm-hmm. 0, 2. That's this one right here. And the other one? Look carefully. It's not on the 2, it's on the
3.
on the 3. Yeah. So this is 3, 0. All right. Thank you, Lauren. All right. So let's go ahead and I'm going to make a little chart just to organize my thoughts because y'all know I'm very visual. I prefer seeing things in a table. So I have 0, 2, and I have 3, 0. Now let's plug that into the formula. So what's my y2?
0.
0. So I have 0 minus 2
Mm.
over 3 minus 0. What is 0 minus 2?
2.
Negative 2, yeah. And then 3 minus 0?
3.
3. And check it out. I got the same exact answer. M equals negative 2 over 3.
Miss, you're not supposed to divide this?
Nope, we're going to keep it as a fraction because remember, this goes back, like I've said before, in algebra. We prefer keeping things as fractions rather than decimals. So I'm just leaving it as a fraction because if I divided it, it would give me a decimal and I don't really want that. Any questions before in the next slide? You guys are going to try this on your own. So do I have any final questions? Awesome. All right, so for these two, you're going to find the slope and you can use whichever method you prefer. But I would ideally like is that for one of these, you try one method. So you could do rise over run. And for the other one, you can do the formula. So it's up to you. But if you want to get practice at both, do rise over run for one of them and do the formula for the other one. Okay, so I'm going to give you guys about 4 minutes to figure out the slope. And when you get your answers, you can put them in the chat. And then, of course, we'll go over it. So go ahead and get started. 4 minutes start now.
Miss Lopez, they already did rise and run for us on.
Yeah, they kind of like drew those little arrows in to make you see it a little easily. So they do it for one of them, but not for the other one. It's about halfway through. 2 more minutes. Remember, you can send me your answers and I'll tell you if you got it. Okay, about 1 more minute left. All right, about 10 seconds. All right. All right, so I've been seeing some good answers and some very, very close answers. So a lot of like your positives and your negatives, we want to make sure we're getting those correct. So I'm going to start with A, and for A, I'm going to use the rise over run. Okay, so for this one, I'm going to do rise over run. Because remember, you could do both ways. You could use rise over run, or you could use the formula. Okay, now they labeled 2 points for us, which is very kind of them, very nice. So sometimes they'll label it, sometimes they won't. Since they labeled it here, we can use the 2 points that they give us. And remember, you're always going to go from one point to the other. So they kind of draw the arrows for us also, which is nice. So this is going up. And how many units is it going up? How many units is that?
5.
5, good. 5 units up. And then this arrow is pointing to the right. So how many units is that?
1.
Good, just 1. Since I'm going up and to the right, are those numbers negatives, positives? What's going on?
Positive.
Positive.
Yeah, they're all positive because going up is positive, going to the right is positive. So both of them are positive. So I have 5 over 1, and 5 divided by 1 is just 5. So positive 5 is our answer for A. Okay, so rise over run. Rise over run. Just remember that. Up and down versus side to side. Rise over run. Now for B, I'm going to use, instead of rise over run, I'm going to use the formula for B. Now, they labeled 2 points for us, which, like I said, that's very kind of them. Very, very nice. But that's not always going to be the case. So what I want to do is I'm going to use just one of those points. I'm going to use this one. But can anyone give me another point that is located on that line? Another nice little point I can use?
2, 0.
2, 0. Very good. That's one. Can anyone give me one more?
4, -4.
4, -4. Beautiful. So what Juan is doing there, and what I want you guys to get in the habit of, is in order to find the point, what you're looking for is a place where that line passes perfectly through the grid. So there's actually one more that I haven't labeled yet. Can anyone see it? Can anyone tell me what it is?
3 negative 2.
3 negative 2.
Yeah, 3, negative 2 right there. So when I say find a point, I mean find a point that's perfectly on the grid, okay? So that's what I was doing there. So I've got a few options, and I'm gonna go with 1 comma 2 because I like that one. And I also like this one, 3 comma negative 2. So those are the 2 points I'm gonna use. Remember, you can use whichever 2 points you want because no matter what you choose, you'll always get the same exact answer. Since it's a straight line, that slope is not gonna change. So you can use any 2 points you want. So I have 1 comma 2 and I have 3 comma negative 2. All right, now I'm gonna plug that all in. y2 minus y1, what do I put in my numerator?
Negative 2, take away 2.
Negative 2 minus 2. And in my denominator, x2 minus x1.
Negative, no, 3, take away 1.
Perfect, 3 minus 1. All right, what's negative 2 minus 2?
4.
Careful, it's negative 4.
Negative 4.
And then 3 minus 1 is 2. So what's negative 4 divided by 2?
Negative 2.
Negative 2, exactly. And that's what you get for B. So for A, the slope was positive 5. For B, the slope was negative 2. Okay, so to summarize everything, I'm going to kind of delete a couple of things here just to make things very clear. To summarize everything, in example A, I had a positive slope. So this was positive. In example B, I had a negative slope. And notice the direction that the line is going in. So in example A, the line, if I go from left to right, my line is going up. I know that there's arrows on both sides, so I'm not really looking at the arrows. I'm just thinking about from left to right. If this was a hill, I would have to walk up that hill. Whereas the other one is a negative slope. From left to right, this one is going down. Even though there's arrows on both sides, that's not what I'm looking at. I'm just thinking about the direction of it. From left to right, I would slide down that hill. So there's a difference between positive slope and negative slope. And we're going to talk a little bit about that in just a second because I have one more example I want to do. But do I have any questions right now on how I got positive 5 or how I got negative 2? Cool. All right, so we're going to do these together, but I want to show you guys two kind of special cases. So in example number 3, what's different about this line in example 3?
It's actually straight.
It's straight. In what direction would you call that?
Wait.
I think somebody said it.
Diagonal.
Vertical.
Vertical,
Oh, wait.
yeah. Vertical. So diagonal is like, these were diagonal because they're kind of going off in an angle. This is vertical. What about number 4? What's that one?
Horizontal.
Yeah, horizontal. Okay. And so what I'm going to do super quick is I'm going to use these points that they give me and use my formula to see what I get for the slope. So number 3, I have 5 comma 9 and 5 comma negative 2. Before I even plug that in, what do you guys notice about these values? We've talked about this before. This is a special.
It's a. I mean, no. It's not. It's not a function. It's not.
Yeah, good. It's not a function because what's happening with the x values?
They have
Repeating.
Yeah, it's repeating, and then on the graph you can see that they're stacked on top of each other. So example 3 is not a function, and that's super, super important. So I'm going to label that real quick. This is not a function. All right, and then let's find out why it's not a function. So if I plug in my values, I would get negative 2 minus 9 over 5 minus 5. Negative 2 minus 9 gives me negative 11. And 5 minus 5 gives me 0. Okay, I want everybody right now to use their calculator, even if you just have your phone. What happens when you try to do negative 11 divided by 0?
Error.
Error. Does anyone get a different answer? Negative 11 divided by 0. What does it say on your calculator when you try that?
Error.
Error. You might get something that says like undefined, or you might get like a word that basically tells you you can't do that. And that's because there's a rule in math that tells you you cannot divide by 0. You can't divide by 0. Because if you think about it, division is like if I have pie, if I have like a cake or a pie or a pizza, whatever, and I'm dividing it, that means I'm kind of handing out slices to a bunch of different people. That's what division is. But if there's no people, if there's 0 people, can I divide my pizza?
No, unless you're dividing it with yourself.
Yeah, but I myself would be one person. So you can divide by 1. I could eat the whole pizza. But if there's just the pizza floating in midair and there's nobody around to eat it, can you divide it?
No.
You can't. So you can't divide by 0, which means in this case, when you have a vertical line that's going straight up and down, the slope, what we call it, is undefined. Undefined. And that's a very, very important keyword, guys. This is definitely going to come up in tests because they love this concept. So make sure this is something we're definitely going to keep in mind. If you have a vertical line straight up and down, first of all, it's not a function, and the slope is undefined. Now, that's different from a horizontal line. Is the horizontal line a function?
Yes.
Yeah, this one is still a function. I'm going to label it green because it's a function.
Miss, does this only apply to vertical lines?
Say that again?
Does this only apply to vertical lines?
Yes. So undefined slope only applies to vertical lines. Because let's see what happens with a horizontal line. I'm going to do the same exact thing. I'm going to make my little table. And I'm just doing this really quick. You can follow along, but you don't need to write everything. But I have negative 3 comma negative 7, and I have 6 comma negative 7. Plugging that into my formula, I would have negative 7 minus 7. Minus negative 7, my bad. I would have that double negative here over 6 minus negative 3. Okay, now I know because I have double negatives, this is negative 7 plus 7 over 6 plus 3, which would be 0 over 9. You can use your calculator. What happens when you do 0 divided by 9?
0.
You just get 0. 0 divided by any number is just 0. So in this case, my slope equals 0. You can kind of think about it like slope is kind of like steepness, like a hill. So if you're walking up a hill, it's positive slope. If you're walking down a hill, it's negative slope. But if you're just walking on a flat line, we've talked about this before. If you're just on a flat line, that means nothing is changing, which is why so that's why the slope is 0. So to summarize everything very quickly, I have positive slope, negative slope, undefined slope, and 0 slope. And what I'm going to do, let me see if I have room. Let me just add I'm going to add a blank, oops. Sorry, it just X'd out on me. Okay, I'm going to add a blank page so that I can, let's see, I know I can do this. Nope. There we go, add page. Okay, so I'm going to quickly draw something that has helped me to remember which one is which. It's kind of silly, so you can use it if you like it, but you can copy this down onto your notebook. It's like a fun way to just remember this. So I'm gonna draw something called Slope Man. And Slope Man is gonna help you remember which one's positive, which one's negative, which one's undefined, and which one is zero. So ready? So Slope Man has these eyebrows. He's kind of angry. Okay, so his eyebrows tell you the direction of the line. His left eyebrow is negative. His right eyebrow is positive. So if your line is going in the same direction as his left eyebrow, it's a negative. If it's going in the same direction as his right eyebrow, that's a positive. His nose goes straight up and down, which is undefined. His mouth is flat, that's zero. So sometimes I like to draw Slope Man on the corner of my notebook because he helps remind me which one is negative, which one is positive, which one is undefined, and which one is zero. So I've got negative, positive, undefined, and zero. So I'll give you guys like 30 seconds to just copy Slope Man down on your notebook. And he's going to be there to remind you in case you ever forget. Positive, negative, undefined, zero. And I can take this time for any questions you guys might have. Okay. All right, so let's move right along. So there's Slope Man. I'll keep him there if you want
Wait,
to copy him. Yeah.
Did you come up with this by yourself?
Mr. St. Rose taught this one to me. So I don't know if Mr. St. Rose came up with it or if he got it from somebody else, but he's the one who taught it to me. Yes, that is a beautiful, beautiful man. The nose is undefined. I saw somebody asked me in the chat, this is a U, and the U is undefined. I'm not sure if that's supposed to be his like nostrils or if he just has a nose ring. I'm not really sure. Maybe he has a nose ring. He's kind of edgy. Okay, so let's get right to it. So we're going to do a couple more. Now that we kind of understand how to calculate the slope, we can always interpret it. Because remember, with these questions and everything we do in algebra always ends up with a real world situation. And whenever you have a real world situation, you can calculate the slope. And then just like we've been doing, we're going to see what the units are and what that means about the scenario. So can I have a volunteer tell us what is going on in this graph? What is this graph showing me? I'm just asking you guys to read. So if anyone just wants to read right there.
The graph shows the relationship between a person's age and his or her estimated maximum heart rate.
Awesome. So age versus heart rate. And so I want to know, what is the slope? So we're going to find the slope and interpret the slope in terms of the context of the given situation. So we're going to find the slope and then figure out what it means, basically. So again, we can use rise over run. We can use the formula. Either way, you'll get the same answer. So I'm going to just go over rise over run one more time. I'm going to connect the two dots using a straight line going down and then a straight line going to the right. Oh, I went too far down. My bad. Hold on. Okay. So actually, here's the thing. And this is important. In this graph, they labeled 2 points for us, which is nice. But what's wrong with the 50, 150? Is that a nice point or is it kind of floating in the middle?
Floating in the middle.
Yeah, it's floating in the middle a little bit. So instead of using that one, because I don't like, it's not going to work if it's floating in the middle. So instead, I'm going to use this one over here, which is it's a perfect point. Okay, so I'm going to use that one instead. So I'm going to go down to here. and then to the right. Now, the important thing in this case is that I'm doing rise over run, but instead of counting the number of boxes, you have to pay close attention to the numbers on your y and x axis, because those boxes are going up not by 1. What are they going on the y axis? What's that going up by?
$20.
Yeah, by 20s. So my rise, I have to count by 20s. I go down 3 boxes, but if I'm going by 20s, that's 20, 40, 60. And since it's going, yeah, since it's going down, it's going to be negative 60. And then same idea to the right, I have to count the number, the actual units. And this is not going by 20s. What's this going by? Each box.
80.
Think again.
10.
Yeah, by 10s, because every number in between goes by 10. So I have to count by 10. So instead of going 1, 2, 3, 4, 5, 6, I would go 10, 20, 30, 40, 50, 60. All right, so there's my rise, there's my run. M equals rise over run. Write that down, rise over run. So in this case, I would have negative 60 over positive 60. And what's negative 60 divided by positive 60?
-1.
-1.
Negative 1. Good. Now, what are my units in this scenario?
Age to heartbeat.
Age, yeah.
Maximum heartbeat per year?
Yeah, heart rate per year. So this one's a little bit tricky, but let me show you guys what we got to do here. So we have beats per minute and year. So for this, it would be -1 beats per minute per year. There's kind of 2 pers. It's a little bit weird, but I'll explain what that means. So what this means is that each year, a person's maximum heart rate, what happens to it? Does it go up or does it go down?
It goes down.
It goes down, yeah. So as you get older, your heart rate goes down by 1 beat per minute each year. So each year, if my heart rate was 180 beats per minute last year, this year is going to be 179 beats per minute. So each year it's going down by 1 beat per minute. Okay, so what can you kind of estimate about a person? What's a general statement you could say about this relationship?
Every year, a person's heart rate goes down.
Exactly. Every year, a person's heart rate goes down. Okay. So, any questions on this problem? How I got those answers, or how I did rise over run?
This one doesn't make sense because when you're a baby, you probably don't have that much heartbeat.
Well, what is
And
it
then when
saying?
you're a little bit older,
What is this actually, Juan? What does this graph say about when you're a baby? What's the heart
that
rate when you're a
you have
baby?
200.
200, yeah, because it's all the way up here. And if you think about it, yeah, this graph is realistic up to a certain point, because after this point, what happens? It would keep going down, 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 down. Okay, so
Yeah.
it is a linear relationship, but it only works up until a certain point, because after a while, you're not really going to live past 120, really. So real world context, sometimes, they have a little bit of parameters. They have like a starting point that makes sense and an ending point that makes sense. So let's do another one. So this time I don't have like the words of this scenario, so we're just using the graph to figure out what it's telling us. So the first thing I want you guys to do is figure out the slope, figure out the rise over run, calculate. You can either use rise over run or you can use the formula, and then tell me what it means. So what are the units and what does that mean about this situation? I'll give you guys about 3 minutes.
What did you say?
Say that again?
What did you say if I didn't hear you?
Oh, no worries. You're going to find the slope. Matter of fact, let me write it down. So calculate the slope. And just like the previous problem, tell me what it means in this context.
It's cold, man.
Yes, Amani, I know. You already know. You've been there a couple weeks. You got to pack a sweater for my classroom. And it's funny because some of you guys, the cold wakes you up, and then some of you guys, the cold makes you sleepy.
Yes.
Yeah. Who is that, Shania? I see you. Okay, about a minute left, guys. You can send me your answers. Woo.
Miss,
Mm-hmm.
not you, Miss Logan.
What? All right, that's time. All right, so this one was a little bit tricky. Can anyone kind of tell me what's a little tricky if you were trying to do rise over run? Did anyone find it a little difficult?
The bottom number is bigger.
Okay, the bottom number is bigger, okay.
And
I did like
there's only 2
1,000,
points.
1,310, and then
Mhm.
I did 1, 2, 3, 4, 5, and then I did it up. I think I did that wrong.
Okay, so you counted rise over run, but here's the thing, and you had to be very, very careful. Maybe I should have zoomed in, but notice, is this a perfect point? Or is it
Not
kind of,
No.
no, not really, right? Is this a perfect point?
No.
Nope.
Not really. So the
I
graph,
only found 2
yeah, there were
perfect points.
only 2 perfect points, and it's not the ones they labeled. What did you see, Juan?
0, 250, and 2,500, 400.
Yeah, those are perfect points. So if you were going to do rise over run, those are the 2 points you want to use. And so if you didn't use those 2 points, you probably didn't get a nice answer because the others were not perfect. So what I'm going to do is I'm going to quickly do rise over run using these 2 points, but then I'm going to use the formula to show if I get the same answer. So what's my rise? You look at the units. It's not going up by ones. What is it going up by?
50.
5.
50. Careful, because it goes from 250 to 300, 350, 400. So if it's going up by 50s, I got 50, 100, 150. And then my run is going up by how much?
1,000.
Not even 1,000. Look at everything in between. Because yeah, if I skip one, it's going by thousands. But if I don't skip, what is it going by?
500.
Yeah, 500s. So this is 500, 1,000, 1,500, and so on. So when I count, I have to go by 500. So it's 500, 1,000, 1,500, 2,000, 2,500. So this is 2,500. All right, so it was a little bit tricky. You had to really make sure that you're counting carefully, because if you don't, you would get different answers. So what I get here, rise over run, would be 150 divided by 2,500. And what does that give you if you use your calculator?
0.06.
0.06.
Yeah, 0.06. Okay, so that's rise over run. Super quick, I'm going to use my formula instead, and I'm going to use the values that they labeled for us in the graph. So the values they gave me were 1,000, 310, and then 3,500, 460. And when I plug that in, I should get the same answer. I should get 0.06. So I have 460 minus 310 over 3,500 minus 1,000. What's 460 minus 310? What do I get in my numerator? 460 minus 8. Yeah, 150. And then 3,500 minus 1,000.
2,500.
2,500. Oh, look, I have the same numbers that I had when I did rise over run. So when I divide, I also get 0.06. So again, both ways work. If you want to do one way and then check yourself by doing it the other way, that's always a good idea because you should get the same answer. And then other than that, if you're using rise over run, the most important thing is to make sure that you're using perfect points. If you're not using perfect points, it's not going to work out. So you just have to be super, super careful. All right, so I got 0.06, and what are my units?
Dollars per page.
Dollars per page. Very good. So it looks like they're printing pages. Maybe they're making books or magazines or something like that. So can anyone give me a general statement about the value or the cost of the pages that you print?
0.06 dollars per page.
And is that a positive slope or a negative slope?
Positive.
Positive.
Yeah, so what happens to the cost as you print more pages?
It goes
It
up.
increases.
It goes up.
Exactly, the cost increases if you add more pages to whatever you're printing. Cool. Do I have questions on this one? I know it was a little bit trickier, so I'm happy to answer any questions you guys have.
It sure doesn't make sense because the cost already starts at 250.
Right, that's and Juan, you're always ahead of me. Right, the cost starts at 250. This is where my starting price. So a lot of times companies will do like, you have a starting price and then they start adding to that. So like wherever you're getting things printed, okay, it's 250 for like as a starting fee. And then from there you add 6 cents per page. So we're actually going to talk about that in, I think, the next slide. Yeah.
Oh, so Miss Lopez.
Mhm.
So if you have like
Here, I'll go
points
back.
that are not even, you just start at the starting point and then you find another point and like.
Yeah, that's a very good strategy, especially, but only if the starting point is a perfect point. Because if the starting point was somewhere in the middle, you would still be in that same, you would still have trouble. So we'll do, I think I have an example like that might help us out. So I'll see if I can answer that question in a little bit. So what Juan was just talking about, the starting price, how did you identify where the starting price was, Juan?
Because of the interval,
Okay, interval,
the y.
the y, okay. The starting price is located at the y, not interval, but intercept. The y-intercept. And we're going to talk about y-intercept and x-intercept now in this next slide. So remember, y-intercept is the place where it crosses or touches the y-axis. And the x-intercept is the place where it touches or crosses the x-axis. So take a look at this graph I have here. And can anyone tell me what the y-intercept is in this graph? Where is the line crossing the y-axis?
0, 2.
0, 2, right here. So my y-intercept is 2. So it's at 0, 2, but the actual y-intercept is just the y value. So here, the y-intercept is 2. What is the x-intercept? Or where is it located? Where is this line crossing the x-axis?
Three.
Mm-hmm. Yeah, right here. 3, 0, which means my x-intercept is 3. And on a graph like this one, it's not really telling us much because this is just a graph, there's no real world context. But when you do have a real world context, it's gonna tell us something. So the y-intercept tells you something about the situation and the x-intercept tells you something about the situation. So what I'm gonna do here is identify the x-intercept and the y-intercept, and then we're gonna figure out what it means in this scenario. So can I have a volunteer read for us this? What is going on here? What am I talking about? Who's reading?
I'll read.
Okay, go ahead, Ashira.
The Sandia Peak Tramway in Albuquerque.
Yeah, nice. So that's the Hispanic way of saying it, but the American way of saying it would be Albuquerque.
Oh,
It's a city. It's a city in New Mexico. So Albuquerque.
Albuquerque in New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function Fx equals 4,500
Minus.
minus 300x gives the tram's distance in meters from the top of the peak after x minutes.
Perfect. So we have a couple of points of information, right? We have a nice little, they give us the function, they give us the equation of this function, they tell us what's going on. So let's just take a look. First up, let's just look at the graph. And looking at the graph, can anyone identify what the y-intercept is? So where is it touching the y-axis?
4,500.
4,500 right here. So that's my y-intercept. And then can anyone identify the x-intercept? You can be approximate, but
Like 15.
yeah, like 15. It's in between 14 and 16, so let's call that 15. Okay. And now let's go back and kind of talk about what this means. So while Ejira was reading, I noticed that she read 45,000, and that matches with the y-intercept. So let's think about what it means. This is telling me that the distance from the peak, because remember, this is a tram, which is kind of like a little train. The train travels up to the top of this mountain. So the distance from the peak, that's the y-axis. What do you guys think? What does the y-intercept tell me is happening at that point? So I'm at 45,000 meters away from the top. So where is the tram? Is it at the peak or is it at the bottom? Where is it? Somewhere in the middle.
At the bottom?
Yeah, it's at the bottom of this mountain, of this hill or whatever. It's I guess a mountain, right? So since I'm still 4,500 meters away from the peak, the y-intercept is telling me that I'm at the bottom, so I'm at my starting location. Oops. So I'm 4,500 meters away from the peak. Okay, that's my y-intercept. My x-intercept was 15. 15 what? What's the units?
Minutes.
Minutes, exactly. So what do you guys think? What does the x-intercept tell me about this situation?
The time
Yeah, the time that it takes to do what?
to reach the peak.
Yeah, to reach the top. Because at the x-intercept, I am 0 meters away from the peak. So that basically means I got to the top of the mountain and it took me 15 minutes. So it's the time it takes to reach the peak. 15 minutes. So notice how not only do we have to be able to identify the number, the value of the x and the y-intercept, but they always tell you something about the graph, something about the situation. So those are very important numbers. Do I have any questions on how I interpreted what they mean? So that's what we're doing. We're interpreting the x-intercept and we're interpreting the y-intercept. Awesome. Let's try one. Oh, sorry, hold on. Let me see if I have another real, yeah, I have another real world. Okay, so I have 2 different types of examples, right? We had just a graph, no context, no real world scenario, no nothing. In this type of graph, you just have to tell me what is the x-intercept and what is the y-intercept. When there's a scenario involved, you also have to tell me what it means. So in this case, all I want you guys to tell me is what is the y-intercept and what is the x-intercept. And in this case, it's not labeled for you, so you have to look at the graph and identify it. So can anyone tell me what is the y-intercept?
0, 1.
Good, 0, 1 right here. It's the place where I'm touching the y-axis or crossing the y-axis. So the y-intercept is 1 because I'm just talking about the y value. What is the x-intercept?
1,
Negative 1, 0. I mean,
Yeah, negative 1, 0. So the x-intercept is negative 1. So again, on this type of graph, it's just about looking and seeing where it is. When you have a real world scenario is when you have to tell me what it means. So let's do an example where you have to tell me what it means. So here it is. I'm going to read the situation, and I want you guys, while I'm reading, to start looking at the graph and try thinking about where it is and what it means. So a hot air balloon is 750 meters above ground, and it begins to descend at a constant rate of 25 meters per minute. The function f of x equals 750 minus 25x represents the height of the hot air balloon after x minutes. So my question is, what is the x-intercept and what does it mean? What is the y-intercept and what does it mean? So I want you guys to take 2 minutes to identify the x-intercept and the y-intercept, and then also to try and figure out what it's telling us about this situation. And if you have an answer, you can send it to me in the chat. So I want to know not just what it means, but the actual value. So what's the number and what does it mean? About 30 seconds remaining. And 3, 2, 1, time. Alrighty. So volunteer, who can tell me what is the x-intercept? What is the x-intercept?
0, 30, 0.
30, 0. Okay, so that's the coordinate point of the x-intercept, but the actual value of the x-intercept would be just 30. And it would be 30 what? What are my units?
Minutes.
Minutes. And what does that 30 minutes represent?
How long it takes the balloon to land.
Good. How long it takes, so the amount of time that it takes for the balloon to land. Perfect. All right, and then what about my y-intercept?
0.
Mm-hmm.
750.
750.
Good.
750.
Perfect. Thank you, Bianca. Yeah, 0, 750. So the actual value of the y-intercept is just
750.
750. And what's the units?
Meters.
Meters. Good. And what does that mean? What is 750 meters?
How much like meters the
Mm-hmm.
hot air balloon goes down for?
Right. So in other words, is the balloon starting at the 750, ending at the 750, or is 750 somewhere in the middle?
Somewhere in the middle.
Starting. Wait. Yeah, starting.
Starting. How do you know that it's starting at 750?
0.
Yeah, because that's when the time is 0. So at the beginning, at the 0, the balloon is up at the top at 750 meters. And from there, what does it do?
It started going up.
It's going up?
Down.
It's going down. Yeah. This is all going down. This is a negative slope. Okay, so what this y-intercept is telling me, the 700 meters, this is the starting height of the hot air balloon. And it kind of tells us that in the problem. It says a hot air balloon is 750 meters above the ground and begins to descend. So it's actually telling us in the words, but you also have to be able to understand it on a graph. So the y-intercept is our starting height. From there it goes down and it takes 30 minutes to land. So it's telling us a story. And if you notice, it's pretty similar to this one, where the y-intercept was the starting location and the x-intercept was how long, the time that it takes to reach its destination. So y-intercept is our starting location and x-intercept is how long it takes. And that's going to be a pattern you guys will notice. So let's do one more. We have 2 more problems and then we're pretty much done. So here, let's do this one together because it's a little bit different. So who can tell me what is the y-intercept? You can be approximate. It's a little bit in the middle, so we can approximate.
$43.
Yeah, about 43-ish,
I'd say 42.
42-ish. Yeah, let's say 42. That works. Now, is it positive 42 or negative 42?
Negative.
Negative. So this is 0, negative 42. And I forgot to read the scenario, so let me read it real quick. What is this? This is a dolphin is underwater and ascends at a constant rate until it reaches the surface. Okay. So now I know what I'm talking about. My y-intercept was negative 42. What's my x-intercept?
$14.
Yeah, 14. So this is 14, 0. Okay. So my x-intercept is 14. What are my units? Seconds. And my y-intercept is negative 42 feet. So let's talk about that. Why is the y-intercept negative 42 feet?
Because the dolphin is underwater.
Exactly, because the dolphin is underwater and this is measuring the elevation below sea level. So if I'm at negative 42 feet, this means that the dolphin is 42 feet underwater. So in this scenario, what happens? The dolphin is at negative 2 feet, and then where does he go? Or she?
To the surface.
To the surface. So is she or he going up or down?
Up.
It's going up. So that dolphin is going up to the surface, which means that 42, and my Apple Pencil might have died. It doesn't really want to write anymore. But anyway, then the 42 is the starting depth of this dolphin, and from there it goes up towards the surface. What does the 14 represent? 14 seconds. There we go.
How much time the dolphin takes to reach the surface.
Perfect. So again, the 42 feet is the starting depth of the dolphin. And the 14 seconds represents how long it takes to reach the surface.
Or how long it was underwater.
Or how long, yeah, for how long was it underwater? The time spent underwater. Both of those are good interpretations, yeah. Okay, so notice, guys, with X and Y intercept, for the majority of these types of problems that you're going to see, the Y intercept is your starting place and the X intercept is your ending place, ending location. Usually it's the amount of time that it takes, but sometimes it's not time, sometimes it's something else. But either way, Y intercept sort of represents where you start and X intercept represents how long it took you to get to your ending place or something to do with the ending. All right. I think it's one last problem because then, yeah, that's all. One last problem. This is more along the lines of what this would look like on a test. So it's a multiple choice question. And can I have a volunteer, our final volunteer for today, read our problem? And I'll give you that first word is, I think it would sit, you pronounce it Pahokee. It's probably like a tribe or something. Who would like to read? Okay, Shamaya's gonna read. Go ahead, Shamaya. You gotta unmute the microphone because I can't hear it.
I ain't seen that. Bonnie said she wasn't read. She lying about this. Let me read it.
All right, Amani, go ahead.
What is it?
Pahokee.
A bulky yacht services charges its customers for each hour they rent a yacht, plus a monthly subscription fee. The graph below models the total monthly cost for the service.
It's a little echoey. I don't know why it's not working so well. Would anyone just like to finish that? Which of the following?
Which of the following shows the hourly rental rate and the subscription fee for the yacht rental service?
Perfect. All right. Sorry about that, Amani. I don't know why it echoes like that, but somehow my sixth and fifth period was able to figure it out. Maybe, I don't know if somebody in the room can talk to them and see how they did it. Okay, it's something to do with like turning the mic down on the computer. But anyways, all right, so we're looking for two things now. I want to know which of these is the hourly rental rate.
Can you put the volume down on the?
And the subscription fee. So before I go ahead and do the problem, let's think about what it is we're looking for. Because now I know how to find three things. Today we've learned how to find the slope. We've learned how to find the y-intercept. And we've learned how to find the x-intercept. So if it's asking me for the hourly rental rate and the subscription fee, which of those three things am I looking for? Am I looking for the slope? Am I looking for the y-intercept? Or am I looking for the x-intercept?
Slope.
Okay, so which of the two is the slope? Is it the hourly rental rate or the subscription fee? In other words, what is rental rate? Is rental rate slope, y-intercept, or x-intercept?
Well, it's saying rate, so.
Yeah, it's saying rate. So what does that sound like?
Rate of.
Yeah, rate of change, exactly. So there's your keyword. That's what we always got to look for, those keywords. So this one's asking me what's the slope? And what about subscription fee? Do you think that would be the x-intercept or the y-intercept? This goes for anyone.
Y-intercept.
The y-intercept. Exactly, because think about what a subscription fee is. if I'm subscribing to Netflix or I don't know, to the gym or to any like a magazine, anything that you have a subscription for, usually they'll say, okay, pay $10 as your subscription fee, and you only pay that the first time. So it's kind of like the starting amount that you pay. So anytime you see subscription fee or like anything like that, most of the time that's going to be your y-intercept. So all right, now we've kind of understand what we're looking for. We're looking for the rate of change, the slope, and the y-intercept. So we only have a couple more minutes. See if you can figure out which of these shows the correct values for the y-intercept and rate of change, slope. Take 2 minutes. All right, there's about a minute left, but I know we're running pretty low on time, so I just want to kind of show you guys this answer and we can finish off the class. All right, so slope is my rental rate. Looking at the graph, there's only 2 perfect points. Can anyone tell me which ones they are?
412
Mm-hmm.
and 0. I mean, yeah, 0.
Yeah, good. Perfect. So I can do rise over run and be very careful because the rise is in thousands of dollars. So when you look, it's 6, the rise is 6, but it's not just 6, it's 6,000. Yeah. And then the run, if I count, every box is 1, so this would be 4. So rise over run would be 6,000 over 4. What's 6,000 divided by 4? 6,000 divided by 4?
1,500.
1,500. Perfect. So I can get rid of answer choice C and answer choice D because I only need these 2. And then for subscription fee, I'm looking at the y-intercept, which is on the 6.
So it's A.
So it's A because that would be 6,000. So that's why my answer would be A. So that's kind of what this kind of problem would look like on a test. Lots of multiple choice answers, but you're still doing the same exact things that we did in class today. So for homework is due Thursday at midnight. I already put it up on Khan Academy. It is 2 assignments. 2 assignments due Thursday at midnight, all right? That is all for today, guys. It is 10:44, so y'all can go. Have a great rest of your day, and I will see you tomorrow.
Bye, Miss.
Bye, guys.
Thomas Lopez.